Okay, let's now look at a parallel circuit. So this circuit's made up of a 6-volt battery and it's set currently to have 0 internal resistance. So it's an ideal battery. We have resistor 1 is 2 ohms, resistor 2 is 3 ohms. So the question I will ask is, what would be the voltage drops across both of these or each of these resistors if I close the circuit? So pause the video and have a think about that. So before we check it, let's have a look at our rule for voltage across components in parallel. The voltage across each of the components is the same as the voltage of the power supply. So from that, you should have predicted that the voltage drop across both resistors should be 6 volts. Okay, and the voltage across the power supply is 6 volts. So they're all the same, except we've got a voltage gain here across the battery and voltage drops across the resistors. Now, what I'm going to do is increase the battery internal resistance, and I'm going to make it 2 ohms. I'll set that as 2 ohms. Okay. I'm going to close this switch here, and notice I've got 2 switches here. I'm going to open this switch up. Okay. So when I close this switch, we've essentially got a single circuit here, and it'll be a series circuit that has an external resistor here and also an internal resistance here that adds to the total resistance. So if I close this switch here, what's going to be the voltage drop across this resistor here? Okay, so we're going to look at an approach for that. Okay, so here's a little sketch. So I've got my battery, and I've drawn in my internal resistance inside the battery, and I've got my open switch here, so that means in effect we've only got a series circuit here. Okay, so we want to calculate the voltage across R1. Now I'm just going to show you another approach for these calculations. So I'm going to write our formula like so. So here's our open circuit voltage. And we know that the open circuit voltage should equal the voltage across the external resistor 1 and plus the voltage across the internal resistance. So we can write it like so. Okay, because this is our rule when we're looking at series circuits. Remember that because it's different for parallel. Now let's just expand on this. I can say that voltage 1 equals the current times the resistance of 1. And I can say that the voltage drop across the internal resistance equals the current times the internal resistance. So if I substitute that into this equation, I get I times R1 plus I times the internal resistance. And if I look at that, I can rewrite that as take the current out, and so that equals R1 plus the internal resistance. Okay, and what we know here is that this value here is the total resistance of the circuit. So what are we trying to calculate here? Well, we're trying to actually calculate the current through the circuit, this as a series circuit. And we do know what this value is, and we know what this value is, and we know what this value is. So we've taken this step to firstly calculate the current, and then we can come back, knowing the current, we can come back and calculate our V1. So I'm just going to substitute straight in because to me it's a little bit easier. So I've got 6 volts equals the current times the 2 ohm for the external resistor plus the 2 ohms for the internal resistance, which gives us 4, which means if we now rearrange, we have 6 divided by 4 will give us a current of 1.5 amps. So I'm just going to write that over here so I can keep track of everything. Okay, so now I know this. I know this. It means I can calculate this using this formula here. Okay, so now to calculate our voltage drop across the external resistor, it's the current. It's current times the resistance will give us 3 volts across there. Let's take a look. Okay, we'll close the switch and our reading is a voltage drop of 3. And so you can work out from here, if we've got an open circuit voltage of 6 volts and we've got a voltage drop across the external circuit of 3 volts, then the voltage drop due to the internal resistance has to also be 3. And we could show that using Kirchhoff's rule. So we can say the open circuit voltage equals that plus that. We know what that is. We know what that is. Therefore, we can rearrange this and say it's that minus that will give us 6 volts minus 3 volts equals 3 volts across the internal resistance. Okay, I'm going to stop the video at this point because the next bit gets a little bit more challenging, I guess. And so we will put the other branch into play. We will look at it firstly without internal resistance, and then we will increase the internal resistance of the battery and look at the effect on both branches.